Hi guys, today we are solving this problem called binary tree level order traversal. This is also the problem of today of maybe coding challenge. The problem is a medium problem and let's read the problem statement. Given the root of a binary tree, return the level order traversal of its node value that is from left to right level by level. So this is basically a generic um, level order traversal, which is breadth first, which we can do either by breadth first search. We should ideally prefer breadth first search because that is what a level order traversal is. So let's see what do we have to output, what do we have to return. So if we are given this tree, we have to return 3 as the first node in the first level. Then we have to return 9 and 20 in the second levels and 15 and 17 in the third levels. We don't have to return the empty spaces. So how we can do this? We have to return a list of integers. So what we can do is whenever we encounter a null value, we can move on to the next part of the list and append whatever has been accumulated in that particular list into the main list. So let's see how we can do that. We will first create a list of lists of integer data type, and we can call this, let's call this result. And we can have a new array list. This is how we initialize an array list. Now, what we can do is we can check the base condition that if root, which is the given tree node, which is given such that is null or not. If it is null, that means there is no tree formed. So we don't have to return anything. We just return an empty result, which we have made until now. As we don't have, as we have not operated with that, the whole result list of list is empty. So we are going to return that. We will just return res. What we're going to do is we're going to form a queue of tree node. Let's call this queue. Now, when we normally initialize a queue, we don't write a queue here. Instead, we write a linked list because here in Java, queue is a type of linked list. Now, after that, we will add the root to queue dot add root because we need to process it further. We are going to process the queue until while queue is empty. Until queue is empty, we are going to process it, and at the end, we are going to return result. Return result. Before that, we have to follow some particular steps, which will go such that we are going to have a variable, let's call it length or size, whatever you want to call it. We have queue size in it. We will have another loop inside of this where we are going to decrement the size and we're going to run until the size is 0. So now we have list of integers. Let's call this current. Now in the current, we're going to save all the list of numericals at that particular level. That is 3 in the first level, 9 and 20 in the second level. These all are going to be saved in current, and then we're going to empty the current into the queue, and from the queue we are going to put it in the list. So let's see how we're going to do that. While, as mentioned, we are going to have another for while loop or for loop. We can have any of those. We're going to decrement size until it is 0. Now we have a tree node where we are going to accumulate all of the nodes. Here also we can have current, let's say n equals to new, or instead of initializing, you can just dot peak or bold, whatever you want to do. After putting out the value from the queue, that is the last in, first out according to queue. So whatever was entered last is going to come out first. So according to that, we have the value inside our current node. Now current equals, now in the current, we're going to add current node dot value. So as in tree, we are saving the node, but the values are placed at a different location, as you can see here. So now we have added that into the current list, and we're going to do that until the size is 0. So after that is done, to calculate that, we are going to have current. We are going to keep adding the currents left and right nodes into the queue until the queue is empty or the size is 0. Node, um, let's say current dot left is until current dot left is equal to null or not equal to null. Q dot add current dot left. So we are going to do the same with right node itself. Instead of left, we're going to write right. Now, after coming out of this, we're going to add our whatever the current is into the result, which is the list of integers. We're going to add our queue elements into that result dot add current, and yep, that is pretty much it. Let's see if this works. Okay, I'm sorry. Current node dot left. Sure, also it should be node. Yes, this works. Let's try to run it on all the test cases. This works. Now let's try to submit it. Our solution is accepted. Thank you guys. I hope you understood. I'll see you again tomorrow. Thank you.